Whoa, it's really hot now, but I have closed the screen to keep the sound better. So look at the tough choices I have to make under global warming to produce these podcasts. Okay, so even in AR5, we had this depiction of global and regional risks and reasons for concern for unique and threatened systems, extreme weather events, distribution of impacts in terms of regional to global scales, and global aggregate impacts and large-scale singular events, with this so-called amber diagram, which conveys risk and impact very high at these hot colors, and then undetectable at the low end, moderate to high in the middle, and confidence levels are mentioned here as well, from very high for 4 dots and low for a single dot here, for example. And we are putting that in the context of global surface temperature change that is projected in terms of an increase relative to the period 1850 to 1900, our baseline. And we are looking here now global warming levels expected from 2021 onwards, whenever this report was finished, so you can see the little gap there. So historic observations and model simulations with the range versus future projections, and the various scenarios projections for SSB 1.9, which is an amazingly benign below 1.5 degree scenario, and then we have 2.6, which is below 2 degrees centigrade, and then we are middle of the road to business as usual up here with SSB 5 8.5. Again, remember, these are combinations of shared socioeconomic pathways and RCPs, which combine the choices, socioeconomic choices on sustainability mitigation, adaptation, energy use, etc., and the resulting emissions and top of the atmosphere radiative forcing. Okay, so reasons for concern, impact and risk assessments assuming low or no adaptation is shown here. So obviously, as we are already here in terms of historical average temperature increase in 2011 to 2020 at 1.09 degrees centigrade with a range of 0.9 to 1.2, so you can see we are butting right up against this 1.5 degree target now, and see the confidence that unique and threatened systems in terms of ecosystems and biodiversity and so on, very high confidence that we are already in the range of moderate to high risks, and then very quickly we are going to get into increasing risks, which we can say with medium confidence, and this is the transition range of risk levels. So extreme weather events, again, we are already there, and we have high confidence here in the observed extreme weather events because we are already in the warming range here. We have already transitioning into increased risks, which we can say with moderate confidence, and then the transition to high risks here can be inferred over 2 degrees with moderate. This color here is beginning to, these dots here are somewhere in low to medium range, right? So distribution of impacts, medium, moderate confidence, but transition into high risks is there. Similarly for global aggregate impacts, large scale singular events as defined in the IPCC that you can look up. So we are facing risks with these transitions happening at the range of warming based on which scenario we end up managing to follow. It's not guaranteed at any event. So other things, impacts and risks to terrestrial and freshwater ecosystems. So again, global surface temperature is on the vertical axis in all of these, and this is impacts and risks to ocean ecosystems, And the next one is climate sensitive health outcomes under 3 adaptation scenarios. So let me leave that for now and come back to these. Impacts and risks to terrestrial and freshwater ecosystems, biodiversity loss, structure change, tree mortality, wildfire increase, carbon loss. Okay, so again, the current level of warming is here, and we have already seen risks going from undetectable to moderate with medium confidence, and the transition to higher risks happening above 2 degrees C with some confidence but maybe lower. Structural change again has a large transition range. Similarly for tree mortality, wildfire increases. There are details here. You can see this scale is higher here in the sense that are the wildfires increasing in numbers, area covered, or intensity of the fire. So those kind of details are reported in papers saying that human management of wildfires confounds these things quite a bit, but nonetheless there is evidence that the extent of wildfires and their intensity is increasing, but you can check on the literature on that. Carbon loss, again, there is already a moderate risk we are in. We can say it with some confidence that's not very high, but we are going to transition into higher and higher risks, and there is already many reports arguing that the Amazon has become a net carbon source now because of the perturbations, changes in temperature, humidity, rainfall, and deforestation, logging, etc. Soil heterotrophic respiration and is bound to increase with temperatures, and already many evidences that it is happening. So obviously that's there already. Impacts and risks to ocean ecosystems. You can see that here again we have warm water corals, kelp forests, seagrass meadows, epipelagic upper ocean, open ocean ecosystems, rocky shores like off of West Australia or Western US in the northwest, salt marshes, which are very valuable ecosystems with high carbon sequestration and many other benefits like filtering the nutrients out before the coastal waters run into the oceans, and migratory birds and all kinds of important effects. I can feel some wind coming, and hopefully the sound quality is not too bad. So again, warm water corals already facing quite a severe risk, and the confidence that we are transitioning into high risk is very high, especially as we reach 1.5, let alone 2 degrees centigrade. So there are many interesting studies going on here, looking at growing corals in the lab, looking at corals that are responding well to warming in some places, and to see what genetic material they have that allows them to grow well in warm waters. There is also the acidification impact, of course, and so on. Kelp forests, again, we are already in the range of undetectable to detectable moderate risk, and transitioning to higher risk with increased warmings. Seagrass meadows have here again transitioning to higher risks, already at moderate risk with high confidence. Epipelagic ecosystems data tends to be a problem, but many satellite data can now tell us the range changes in many of the phytoplankton and related food webs and so on. Unlike on land, we don't have that much data on the ocean, which is always an issue. Rocky shores, you can see that there is a transition to moderate risk expected right now, undetectable so far, but with some confidence we can say we will transition to medium risks if we cross 1.5, or when we cross 1.5, because we are definitely going to cross it, and unless major game changer comes along and starts sucking down carbon dioxide like Coca-Cola. And there is risks to risk of transition to high risks for rocky shores, but confidence goes down, and similarly for salt marshes, already there in terms of medium risk. We will cross again into increasing risks by warming above 2 degrees centigrade. Okay, so I will come back and look at the details of these examples of regional key risks with additional global surface temperature change continuing here. But let me stop this one here because I don't want to cram too many details into one podcast so that your attention span remains intact and the information is enough that you can absorb and listen again without having to do that because it's too long. Okay, so let me stop that here then.